guys, Mr. Bankerberg here. In this video, I'm going to be running through the review for test number 10. Taking a look at problem number 1, we're asked to use the law of sines to solve this triangle. Now we're given two angles and one of the sides. Since we have two of the angles, I think it would be really easy to find the measure of our third angle, since we know the angles inside of a triangle have to add up to 180 degrees. So A plus B is going to be 30 degrees, so for the measure of angle C, that's got to be 150 degrees. Now from there, I think I would start finding our missing sides. So first, let's start off and find side B. So I'm going to go B over the sine of angle B, which is 17 degrees, equals, now for the other side, we need a pair of matching information. So we know what side A is, and we know what angle A is. So we're going to go 5 over the sine of 13. Now I'm going to take that sine of 17, multiply it over to the right-hand side, and type everything into my calculator. When I do that, I end up with a B value of about 6.5 if we're rounding to the tenths. Now to find side C, we're going to go C over the sine of angle C, which is 150 degrees, equals, again, I'm going to use that information about A since we have side A and we have angle A. So I'm going to go 5 over the sine of 13. Again, I'm going to take this sine of 150, multiply it over to the right-hand side, and type everything into my calculator. When we do that, we get a length of C to be about 11.1 if we round that to 1 decimal. Take a look at problem number 2. This one is an area problem. So we're given an angle and two sides. So what we're going to do is we're going to use the formula that says in order to find the area of a triangle, we can do 1/2 times the length of the two sides, so 23.5 and 53.15, times the sine of the angle between them. So this is our 42-degree angle. And when we type all of that into our calculator, rounding to 1 decimal place, we get about 417.9 units squared. For problem number 3, we're using the law of cosines to solve this triangle. Now we're given two sides and angle C. I think it's going to be easiest for us to find side C first. So in order to find side C, we're going to go C squared equals our A squared, so 7 squared, plus B squared minus 2 times A times B times the cosine of angle C. Now when we type all of this into our calculator, we get about 107.23, but we have to remember that's our C squared value, so our last step is to square root both sides, and when we do that, we end up with a C value of about 10.4. Now let's go ahead and find angle B. So in order to do that, we're going to go with the cosine of angle B equals A squared plus C squared minus B squared all over 2 times A times C. When we type this into our calculator, we should get 0.0904, but this is the cosine of angle B, so we're going to have to do the inverse cosine to find the measure of the angle. So angle B ends up being about 84.8 degrees. And then we can use what we know about triangles and the angles needing to add up to 180 degrees in order to help us find angle A. So if we take 180 minus the two angles that we already have, angle A ends up being about 35.9 degrees. For problem number 4, we've got kind of an application problem or a word problem. It says we want to measure the diameter of a crater. So let's draw this out. So here's our crater, and it says camp is 4 miles away from the northernmost point. So let's say our camp is right here. So the northernmost point up here to the camp, that distance is 4 miles. And then the southernmost point is 2 miles away. So here's our southernmost point to our camp. That distance is 2 miles. And we know the angle between these two lines of sight is 117 degrees. So it doesn't look like it in here, but this angle is supposed to be 117 degrees. So we're trying to find the diameter of this crater, so the length across the middle. So we're going to use our law of cosines since we don't have any opposite pieces of information. I'm going to label my triangle. I'll call this angle A, I'll call this angle B, and this angle C. So the side that we're trying to find over here is side A. So we're going to go with the formula that says A squared equals our B squared, which is 4 squared, plus our C squared, so 2 squared, minus 2 times 4 times 2 times the cosine of our 117 degree angle. When we type all of that into our calculator, we should get about 27.26, but this is our a squared value, so in order to find a, we'll have to square root both sides. So we end up with an a of about 5.2 miles. So that's the distance across the crater. That's our diameter of the crater, 5.2 miles. Taking a look at problem number 5, we're asked to use Heron's formula in order to find the area of this triangle. So we've got the three sides given to us. In order to use Heron's formula, we're going to need to know what our semi-perimeter is. So that means we have to add up all the sides and then divide by 2. So when we do that, that S value, or semi-perimeter, ends up being 8. So now if we set up Heron's formula, it's the square root of our S value times S minus A times S minus B times S minus C. Now we can just type all of this into our calculator. When we do that, we get about 9.8 units squared. For number 6, we're asked to do two things. We're given our initial point and our terminal point. We're asked to figure out our component form for the vector, and then after we have that, we're going to find the magnitude of our vector. So when we're finding the component form, we take terminal point minus initial point. So we're going to take our 1, 7 point minus our negative 2, 3 point. So if we take 1 minus negative 2, well, double negative turns into addition, so that ends up being 3, and 7 minus 3 is 4. And then we put the pointy arrow brackets around the outside to show that it is, in fact, a vector. So this is the 3, 4 vector. Now, in order to find the magnitude of vector v, we're going to go with the square root of, using our component form, we're going to take the 3 squared plus the 4 squared. 3 squared is 9, 4 squared is 16. If we add those together, we get the square root of 25, which is just 5. So the magnitude of vector v is 5. Taking a look at problem number 7, there's actually 3 things you're asked to do. In part A, we're asked to take our vectors u and v and add them together. So our vector u is the 12, negative 5 vector, plus our vector v, which is 3, 4. When we're adding vectors together, we just want to add up the individual components. So adding up the first pieces, or the x pieces, 12 plus 3 is 15. And then if we take negative 5 plus 4, we get negative 1. So this is the new vector 15, negative 1. Part B, we're asked to subtract these vectors. So we're going to take u, which is again our 12, negative 5, minus our v vector, which is 3, 4. And again, we're just going to subtract the components. So 12 minus 3 is 9, and negative 5 minus 4 is negative 9. So there's our new vector. For part C, we're asked to do a little bit of multiplication and then add some vectors together. So we have to do 3 times vector u. So 3 times our vector 12, negative 5, plus 2 times our 3, 4 vector v. I'm going to take care of this multiplication first, and it works pretty much like the distributive property. So we're going to distribute the 3 inside of here to get 36 and negative 15. Now we have to distribute the 2 inside of that other vector, so when we do that we get 6, 8, and now we're just going to add up the individual components. So 36 plus 6 is 42, and negative 15 plus 8 is negative 7 for that vector. In problem number 8, we're dealing with the same u and v vectors, and we're asked to find the dot product of them. So doing the dot product is where we multiply components together and then add the results. So if we're looking at u dot v, we're going to take our 12, negative 5 vector and dot it with our 3, 4 vector. So we multiply the x's together. So 12 times 3 is 36, plus multiply the y's together. Negative 5 times 4 is negative 20. And then if we take 36 plus negative 20, we end up getting 16. For problem number 9, we're asked to find the angle between our two vectors, again dealing with our u and v from before. So the formula that we're going to use says the cosine of theta equals u dot v over the magnitude of u times the magnitude of v. So we're going to go ahead and figure out what these values are. Now we just did the dot product on the last problem, so when we do u dot v, we're going to end up getting 16 over, now we need to find the magnitude of u, or the length of u. So if we do the square root of 12 squared plus negative 5 squared, 12 squared is 144, Negative 5 squared is 25. If we add those together, we get the square root of 169, which is 13. So I'm going to put that on the bottom of my fraction. We also need to find the magnitude of vector v, so that's the square root of 3 squared plus 4 squared. 3 squared is 9, 4 squared is 16. If we add those together, we get the square root of 25, which is just 5. Now, looking at our fraction, on bottom we have to multiply the 13 and the 5, so we've got 16 over 65. Now, this is the cosine of angle theta, so in order to finish this, we'll have to do the inverse cosine of that fraction, and when we do that, our theta angle ends up being about 75.8 degrees. That's going to be it for this video. Thanks for watching.